It's the early 1990s. Inside the highly secure labs of India's DRDO or Defense Research and Development Organization, engineers are sweating over a massive thermal problem. They are building the Agni missile, a critical pillar of India's nuclear deterrence. But a chance encounter on the ground is about to pivot this lethal defense technology into one of the most profound humanitarian breakthroughs in Indian history. How did a material engineered to survive a 1200-degree missile re-entry end up lifting a heavy, painful burden off the legs of paralyzed children? Today, we are looking at the incredible hidden history of how India's nuclear defense program gave thousands of kids their childhood back. When you think of Dr. APJ Abdul Kalam, you probably think of rockets and the Agni missile. But his most emotional and the most arguably important technical breakthrough didn't launch into space. It stayed right here on the ground, helping paralyzed children take their very first steps. Today, we're looking at the engineering of FRO polio calipers, how missile heat shields were redesigned to help children walk. If you are enjoying this series on how weapons of war turn into civilian miracles, please hit that subscribe button so you never miss an episode of Hidden History. In the 1980s and 90s, India was fighting a brutal, quiet war against polio. Thousands of children were left with paralyzed or severely weakened lower limbs. To stand or walk, they relied on orthopedic calipers. But the existing medical technology was medieval. These calipers were fabricated using heavy steel rods, thick leather straps, and wood. A single caliper weighed anywhere between 3 to 4 kilograms. Imagine being a 5-year-old child already weakened by a virus, forced to drag an extra 4 kilos of dead weight just to take a single step. The sheer exhaustion meant many children simply gave up, abandoned their calipers, and resorted to crawling. During a visit to an orthopedic clinic, Dr. APJ Abdul Kalam, the mastermind behind India's missile program, watched a young girl struggle painfully to move with these heavy steel braces. Deeply moved, he returned to his defense lab with a radical directive. We have the advanced materials, why can't we lift the weight of these children? Dr. Kalam was constantly finding ways to use defense budgets for public good. Have you ever heard of this specific story about him before? Let me know with a yes or a no in the comments. To fix this, defense scientists collaborated with medical experts to replace heavy steel with the exact same glass-reinforced plastic and carbon composites used in the nose cones of the Agni and Prithvi missiles. The engineering shift required reimagining a military material for orthopedic biomechanics. The weight eradication, carbon-carbon composites possess an incredibly high strength-to-weight ratio. By substituting steel with these molded composites, engineers managed to slash the weight of the caliper from 3,000 grams down just to 300 grams. A staggering 90% reduction. Traditional calipers just held the leg straight. The new design utilized an engineering concept called flow reaction. The rigid, lightweight carbon structure was modified to fit the front of the shin. When the child's foot hit the ground, the material absorbed the ground reaction force and used that energy to push the knee straight, assisting their natural walking gait. Unlike steel rods that had to be awkwardly bent by hand, these advanced composites could be heated and vacuum molded to perfectly match the unique organic contours of a child's leg, eliminating the painful friction source. We're about to see how this military technology scaled to the entire country. If you think this is one of the best examples of engineering we have covered so far, hit the like button right now. What started as a high-budget defense project quickly pivoted into a massive social mission. DRDO transferred the manufacturing technology to medical institutions and NGOs across India. Because the materials were being produced at scale for the defense sector, the cost of manufacturing these ultra-lightweight calipers plummeted, making them affordable for impoverished families in rural India. Tens of thousands of children who were once confined to wheelchairs or crawling on the floor were suddenly handed a 300-gram miracle. They could not just walk, they could run, climb trees, and go to school independently. By the time India was declared polio-free decades later, the composite technology developed to protect nuclear-capable missiles had already rewritten the destinies of countless children. Without the intense geopolitical pressure of the Cold War era that forced India to develop indigenous missile composites, the material science required to create the FRO caliper would not have existed domestically. It took a program designed for national defense to deliver the ultimate tool for human liberation. Every time we look at the advanced aerospace materials, we think of rockets breaking the sound barrier. But in India, that very same space-age carbon fiber is celebrated for doing something much more grounded, helping a child take their very first step. What's the next war tech turned civilian application you want to see? Let us know. Don't forget to like and subscribe.